So we started this unit off with different kinds of triangles, and we're going to end it with isosceles triangles, the special kind. There's a lot of congruent stuff going on in isosceles triangles alone. Let's start out by checking out the definition. You already know an isosceles triangle is a triangle that has how many congruent sides? We're going to say at least 2. So really, at least 2 means it could have 2 or it could have 3, but we're going to start out with at least 2. All right, let's get some vocabulary under our belts first of all. The congruent sides, the 2 sides that are congruent, which I'm going to mark right here in blue, those have a name, and those 2 sides are called the legs. So each one is considered a leg of the triangle. 2 legs in every isosceles triangle at least. And then we've got this angle here, which, let me change colors, this angle right here where the 2 legs come together, that's called our vertex angle. Sometimes we just say it's the vertex of the triangle. That's the vertex angle, though, this angle right here. What about those other angles? Well, before we do those, let's talk about this third side. This third side right here, we refer to that side as the base of the triangle. Now, I should clarify, just because it's at the bottom of the triangle doesn't mean anything. We could flip this thing around, turn it upside down, and the base would still be this third side. It's the side that's not congruent. So what does that mean these 2 angles are? Well, these 2 angles here, right here, and the second one here, they both have the same name. Since they are including the base, they're called base angles. And we're going to learn some things about the base angles today. Base angle, you can just scribble that, base angle. So we have 2 base angles, 2 legs, a vertex angle, and a base. All right, get all that straight. So we got a theorem. The isosceles triangle theorem says if a triangle is isosceles, so let's sketch that. So we've got an isosceles triangle. We know 2 sides are the same. Then what can we say about the base angles? This is one that a lot of people can really just guess by kind of looking at it. We can say that those base angles are congruent also. So this is our hypothesis. We start with congruent sides, and that tells us that 2 angles are the same. So the base angles are congruent. I just spelled congruent really wrong. Congruent. There we go. Now, why is that true? Well, basically, a quick little illustration of this. If I've got my isosceles triangle, essentially I can say, know that these are congruent, and we're going to just say, one way I could do this is say, let me take the midpoint of this base. Every segment has a midpoint, and this is it. So if I say that's the midpoint, well, what's going to happen if I were to draw in a line connecting that midpoint from the vertex, which would be congruent to itself? I'm just going to get 2 congruent triangles. And since, well, how would those triangles be congruent? Those would be side, side, side congruent. And since the triangles are congruent, I want to say these base angles are the same, and I can say that by the corresponding parts of congruent triangles are congruent, or CP/CTC. So that's one way we could prove this. Now the converse. The converse is where we're going to switch everything around. You guys have done this. We haven't done this in a while, though. Let's practice it. So switch around this hypothesis and conclusion. So in the hypothesis, we're going to say that if we know the base angles of a triangle are congruent, we've got 2 congruent angles, then we're going to be able to conclude that we have 2 congruent sides also, or that the triangle is isosceles. So if the 2 base angles are congruent in a triangle, then we would know that that triangle is isosceles. The triangle is isosceles. Very cool. Okay, so in a nutshell, this is what we're saying. And remember this picture. If you've got 2 congruent sides, then you also have 2 congruent angles. 2 congruent sides means 2 congruent angles. And those 2 angles are going to be right across from those 2 sides. So they're going to match up like this. That's what you need to know. Let's look at lots of examples to help clarify this. All right, I see 2 congruent sides. I have to find this x angle. I'm going to point to the 2 angles that must be congruent. They come straight out from those sides that are congruent. So this angle and this angle have to match. So here's what I'm going to do. I'm going to take 180 degrees, the total in the triangle. I'm going to subtract out the 80 that I know, and that's my vertex angle right here. I'm going to take the vertex angle away, and that leaves me 100 degrees. And that 100 degrees is going to have to be split equally between these 2 angles. And so 100 degrees divided by 2 that's going to give me 50-degree angles. So I've got 50 degrees here, and my x value is also 50 degrees, so x is 50. Pretty cool. Okay, let's get a little complicated. I see two triangles, and they are both isosceles. So this first one, and then this second one's marked isosceles. We got to find our angle x. I don't know anything about this triangle's angles, but I do know this is 70, and I do know from my isosceles triangle theorem that these two angles across from those sides match, that they are congruent. So this is equal to this. So let's do that the same way we did the last one. Let's take 180 and take away the 70 degrees that we have in our vertex angle. That'll give me 110. I'm going to divide that by 2 since these are equal angles left over, and that's a 55-degree total. So each of these is 55. Let's squeeze it in there, and 55 here. And then I can get into my next triangle with this little link right here. That's a vertical angle, so this is also 55. And in my second triangle, I have isosceles, or two sides the same as well. So that's going to mean that this angle matches this angle. So if that's 55, then over here is 55. And I've got a lot of information now. I just have to figure out that last angle. Let's take the 180, and let's subtract out the 55. Well, what's 55 plus 55? We've got two of those. So those combined together make 110. We're going to take out 110, and that gives me a 70-degree angle for angle x right there, 70 degrees. Sweet. I like this theorem. Okay, this is actually one of my favorite theorems. It's pretty fun. All right, so now I've got another set of congruent sides. I know these two angles are going to match. Don't know anything about them. Going to have to use some other information. Notice right here, guys, look at here. We've got parallel lines. Those arrows are showing us that. So back to our parallel line theorems, this 62-degree angle here, let's just follow this transversal down and find out something about an angle down here. See that Z that I've made? That's the alternate interior angle. So you should be able to tell me that this angle is a match to the 62-degree angle. 62 there and 62 here. And then our isosceles triangle theorem is going to mean that 62-degree base angle matches the angle over here. And then we've got 180 to find out what's left over. So 180 subtract what's 62 and 62 combined. Looks like that's 124. So I'm going to take 180 minus 124, and I'm getting 56 degrees. So x is 56 degrees. Okay, so a lot of old theorems coming in with the new. Cool. All right, oh, awesome. Love the ninja. This is going to be some algebra, so we're going to do some hee-haw in here. Sounds like a country music thing. Okay, so, oh, look at this. I don't know anything about the sides here. Instead, they told me that I have some angles congruent. So this is our converse. We got base angles that match, and that means that they are pointing opposite the triangle to some sides that match. So these two sides are going to be matches in this isosceles triangle. That means I get to just take those two expressions and set them equal to each other. So I'm going to get that 3x minus 2 set equal to this other leg of 16. And let's let this ninja do his work. Alrighty, this guy's telling me to add 2 to both sides. Yeah! And 3x is left, making 18 over here. Dividing by 3. I love how he's staring at it. Yeah! And x is magical 6. X is 6. I don't know what I was asked to do on this, find x or find the measure. I don't have my notes in front of me, so let's just go ahead and find the measure too. Okay, so back over here, putting in that 6 for the x, I'm looking at 3 times 6 minus 2 is 18. 18 minus 2 is 16. So this side is 16. Oh, duh. I knew that. It matches over here. Well, good. That checks. We did it right. Okay, another ninja one. Another one where we've got two angles matching. This triangle would have to be isosceles, and that means this side right across from over here, this side, these two sides are equal. I'm not going to use the 10. I'm going to ignore that. That was there to make sure you knew which side to match up. So 13x minus 18. That leg is equal to 8, this other leg. And let's solve this thing. Alrighty, bring in the ninjas, adding 18 to both sides. Yeah! And that gives me 13. Now I got 13x on this side, and 8 and 18 added up make it 26. Oh, I gave you a nice one. So dividing by 13. 13 divides nicely into 26. No decimals this time. X is equal to 2. X is 2. Sweet. A lot of this is sweet. I think I'm hungry. Okay. Now, Before we end this lesson, let me just tell you about a corollary. And a corollary may be a new word to you. A corollary is a theorem. It's just another theorem where the proof of it is just so easy. It just comes as a direct result of a theorem. So it's called a corollary. And it's about equilateral triangles this time. So now if we have 3 equal sides, if I've got a triangle and all 3 sides are the same, so 1, 2, 3 sides match, what conclusion can I make? Well, I know that if it's equilateral, it's isosceles too. So these 2 sides are going to match, but then this third side matches, and that means all 3 angles are going to match. So that's our conclusion, actually. If you have all 3 sides of a triangle that match, then it would make sense that all 3 angles are going to match also. So what is the name for that? All 3 angles the same. The triangle is equiangular. The triangle is equiangular. E-Q-U-I-A-N-G-U-L-A-R. Spelled right down here. And the reverse is true, the converse of this. If it's equiangular, then it is equilateral. So if you are looking at a triangle and you have some information about the 3 angles being equal, if you know that that's equilateral, then you can also conclude that not only are those angles equal, but so are the sides. So you'll be able to just tick mark the 3 sides also. Awesome. How many degrees would be in each of these angles? That's another really good thing to know. It'll actually be a nice shortcut if you know that. So if all 3 angles are equal, if you take the 180 total and divide by 3, that means each one's going to be 60 degrees. So you might have to find the angle measures at some point. And if you know it's equiangular for a triangle, each one of those is 60-degree angles. Nice to know. Okay, hopefully you like this one. I think this is a pretty fun theorem. You're going to go ahead and try these a shot, and then we'll talk about this more tomorrow in practice, of course. That's the end of our unit. Cool deal.